All right, welcome back. This is the first video for week 3. We are going to continue our discussion of equations and their graphs with a certain class of equations called conic sections. So conic sections are going to include a few different types of curves that we've seen before and that you've heard of, and then maybe a couple that you haven't. So actually, before I explain the page I'm on right now, I'm just going to go show you the different types of equations that you can expect to see. One type of equation we're going to see is circles. And so we're going to study equations of circles and their types. Another type of equation we're going to see is the equation for an ellipse. So ellipses of different shapes and sizes, and we're going to learn about those. Another type we'll look at is hyperbolas, which are in some ways kind of like an inside-out ellipse. They don't look anything like that. They have this weird sort of arcing shape that like two pieces that don't intersect each other at all. You can see they kind of go out forever. So that's an ellipse. That's a hyperbola. And then the last shape is a familiar shape, the parabola, which you know from studying like quadratic equations in your previous classes. So we're going to be studying these 4 different shapes. Circles are kind of a special case of ellipse, but you'll see why soon enough. So the reason they're called conic sections is because you can obtain all of these curves by taking a cone, which in mathematics a cone is kind of an uh, infinite cone shape that goes on forever in all directions, and it's a circular thing. Basically, it's a slanted line which is revolved around an axis, giving you a top and bottom half. So this brown orange kind of colored surface here in 3 dimensions is a cone. And if you take a flat plane and look at the intersection curve of the cone and the plane, so where the flat plane sort of slices through the cone, you can see a curve, and that is a conic section. So in this case, I have we are looking at the plane slicing straight through this cone, perpendicular to its axis, running through the middle, and we get a circle. That orange thing right there is a circle. If you look straight down on it, it makes a circle. If you tilt it a little bit, you see it change color, it turned green. This right here, looking straight down on it, is now an ellipse, which means it's kind of like an oval. If I keep tilting this, I can make bigger and bigger ellipses. I can also move my plane up and down, so I can intersect the top half or the bottom half. Either way, these are ellipses at the moment. But if you keep on moving this, at some point, whoop, snap, right there. At some point, there's a particular angle where actually the plane and the cone, the edge of the cone and the plane are are parallel to each other, so they're at the same angle. That is where we get this parabola shape. It's a very specific angle, and we can get different parabolas depending on whether our cone is slicing through the top half or the bottom half. They can be skinny, they can be wide, but we can get parabolas at that angle and then go beyond that angle. And if we go a little further beyond that angle, then our plane begins to intersect the cone in more than one spot. So we see it intersecting down here on the bottom and also intersecting up here at the top because it's so tilted that it is catching, sort of like cutting through both parts. All right, so those are different, those are hyperbolas now. So those are the 4 different types of curves you can get. I'm going to show you another visualization. In the previous one, we had the cone static and the plane was moving around. In this one, I've programmed it so that the plane is static and the cone can move around. So here, I can take this cone and I can shift it up and down. And currently, what I'm getting when I shift it up and down, if I look at the intersection with the plane, you'll see I'm getting circles of different shapes. That black curve right there is the intersection. So I can hide the red cone, and you can just see the intersection there. That's the circle. If we take that cone and we tilt it, there we go. I like to think of this as like a flashlight radiating away. So like if there's a flashlight right here, and the beam of that flashlight is sending light rays out in this cone shape, then the ellipse that you see right here now, that intersection curve right there, let me hide the cone entirely so you can just see the curve. That intersection curve is like where the flashlight's beam is landing on the ground, and it makes an ellipse. So that's an example of an application of these things, by the way. It's the shapes that you can make with the beam of a cone-shaped beam of a flashlight when projected on a flat surface. So we can make different ellipses by changing how much the cone is angled, and also by shifting its center around a little bit from side to side and left and right, that kind of thing. Bringing our cone back here, if you tilt that cone really far, there's a certain point, a very specific point there where it's going to form a parabola. That'll be your, that's not a parabola, that's a hyperbola. But there's a very specific angle where you can get a parabola there. And then if you go beyond that angle, which by the way is 90 degrees tilt, you go beyond that 90-degree tilt, then you get the cone now intersecting plane in both of its sides. So that's the hyperbola. There we go, looking down on it, hiding the cone and looking down, we see the hyperbola. So there's a couple of visualizations for the two, for all four different types of shapes that we're going to be looking at here. So we'll do it for the first video.